Before we get started, I wanted to provide a summary of CamLogic for those of you that may not be familiar with our organization. CamLogic is a holistic engineering solution provider leveraging PLM software, manufacturing, and quality control. Our success is a result of a longstanding commitment to our customers, our region, and the industries we serve. Our business model, or wheel, illustrates our go-to-market approach and 4 value-driven offerings. Conceive, which is our engineering and design team. Develop includes our Siemens software offering. Manufacturing, we're a tier 1 supplier that leverages both the conceive and develop sections of the wheel to deliver customer solutions. Capture is our quality control group that makes sure those solutions are of the highest quality. Let's go ahead and run through the agenda real quick, and then we will hand things over to Jason and get started with the presentation. Some of the topics we will be covering today is an introduction to Design Configurator, some industry trends, workflow and processes, benefits of Design Configurator, the Design Configurator potential, and then we will be having a Q&A and talking to you about some promotions running now. When we do the open Q&A, which everyone feel free to put any of those questions in the chat or in the Q&A tab at any time throughout the webinar, and we will be sure to get to those questions first. And then lastly, we're going to finish things off with information on a Design Configurator promo that is currently running from now throughout January 31st. And with all of that being said, Jason is going to take it from here.
Thanks, Joanna. So today I'm going to be covering Solid Edge Design Configurator, a little bit of an introduction into the Design Configurator add-on for Solid Edge. First thing is that the Solid Edge Design Configurator is an add-on that allows you to automate your designs within Solid Edge. You can configure your designs quickly by automating design changes using things like parameters, rules, and model actions. In short, it's almost like programming your assembly or model. And these are defined within Solid Edge inside the Design Configurator pane. In that pane, it guides you through step by step, through each step of the process in order to create and then run your configurations. I've been an application engineer for Solid Edge for about 3 years, and this is probably one of my favorite tools, partially because of my background with programming and things like that. But I really do think it's a powerful tool. Some of the industry's trends and challenges that we've seen recently is that there's been a large increase in demand that customers have for customized products. They want more customization, they want it to still be delivered quickly, and they, of course, as always, we want things at a competitive price. And manufacturers have also seen an increase in the amount of product configuration that they have been performing. And the predictions show that that's only going to increase further. Kind of like we already said on the previous slide, that the increased complexity, the number of choices have all been increasing, more variety without the added cost involved, and a mix of other things. A good example would be just with cars is a good one. Way back in the day, your option for vehicles was, maybe 3 or 4 different options, not a whole lot of colors. But nowadays, there's a whole customization page on every automotive website that lets you pick and choose features, whether you want heated seats or not, and what kind of car you want to drive. Of course, color is really important here. Some other industry trends that we've noticed is that manufacturers have been differentiating themselves by offering higher levels of customization and continuing to meet the specific needs that a customer has with each order. and then continuing to improve that product reliability and support. When making these changes, though, and doing these configurations, it requires a pretty significant amount of engineering work, and not just in the design changes, but also making sure that the bill of materials, CAD models, and drawings are all accurate and specific to each configured model. This would be kind of the typical process that a company has when they get a request for a proposal. Typically, the customer requests a proposal, and the manufacturer then has to review the proposal, and which usually requires a bit of engineering work. Once the engineering work is done, only then can the manufacturer respond to the customer's proposal. This leads to a bit of a bottleneck with the engineering work. It can lead to lower win rates, longer lead times, and a bit of margin erosion because of the time it takes for some of these changes to process. Similarly, with just a regular ordering process, the orders that come in from a customer frequently have to be processed and sent to the engineering department so that they can analyze the requirements, configure the designs or products, and only once those designs have been completed and analyzed can it now be sent over to manufacturing. Again, this leads to longer lead times and margin erosion, but on this end, it also slows new product development because that engineering time goes into configuring existing products rather than developing new ones. With a design configurator tool, you can minimize that engineering bottleneck. You can reduce the amount of proposal lead time. There's less margin erosion from cost overruns and the amount of time it takes to configure these orders. You can get your bids in sooner and faster. There's also that reduction in design effort because those configurations don't require as much design time. The engineers are able to process those requests much faster. And then, of course, because of the automation, the bill of material and drawing accuracy is increased. Some of the other industry trends that have been shown through this independent study was that the return on investment is pretty high for product configuration systems. You can see some of the statements here that have been seen throughout the industry. All in all, I do think that's a very powerful and a good tool. And like I said at the beginning, it is one of my personal favorites, if not my favorite tool that can go along with Solid Edge. Now, I talked about some of the industry trends, and I gave a brief introduction of Solid Edge Design Configurator, but I'm going to talk a bit more now about the specific workflow and process. How does this tool work? Here I've got a short demonstration. This is a very simple model of just a table, but I'm going to start by showing how we add a couple of the models to this configurator. So I added the two models that I need because the 4 legs are all identical. And now I'm going to add my inputs, which are basically the variables that I would use. So this is sort of that initial setup. How do we get from a normal assembly to a configurator assembly that can be configured faster? Typically, when you do configurations, I would have to go into each part and edit them manually, each dimension, whether it's height, length, width. But in this case, I'm doing a very simple demonstration just to show how setting it up works. So I added my variables, my inputs, and now I'm going to add the variables of my model to the model actions. So first I reference my height. and then I'm going to add an expression. So this expression here, input.height, there's a validation tool at the bottom that lets me know my expression is valid. So I've set the height of the legs to be the same as the input height. Same here, I'm going to set two more variables, length and width, and they're going to be set to input.length and input.width respectively. So the first time I showed using the expression menu, but if you know what they are supposed to be, you can type them in yourself. And then I used the check rules function to verify that my rules are valid. Then I can type in a couple of random measurements in millimeters in this case, and my table will configure itself. What I'm going to show now is a couple of other things with rules. So what I did originally was setting model actions. This is more about rules. What I'm checking now is whether the input height is greater than or equal to 900. And all this will return to me is whether is yes or no. And so I'm going to call this too tall. This is just an example rule to show what can be done with the rules and how to assign limitations. So those are length and width, but what I need to set is height. So I'm going to add a run condition, which is too tall, and then I'm going to make sure and only run if too tall is false, because if it's not too tall, then we can run it. So I could run it the way it is now, and it would only run, it'll only run if that height is below 900. So I'll leave everything, change a couple of the other values. You'll notice that when I ran it, the other values changed, but the height did not. I'm also going to add a couple of other things that are possible here. So I'm going to add a regular command. That's going to be a message. And I'm going to say that height must be less than . Yeah, height must be 900 or less. Add my millimeters in there. And then I'm also going to add another rule so that that this one only runs when too tall is true. And then the last thing I'm going to do is add an exit restart. And I'm going to do the same thing so that it only runs if too tall is true. And what this does is by adding that in, the command or the configuration won't run at all. It'll just reset if too tall is true. So it'll give me a warning, it reset, and no changes happen. And then, so that is a quick demonstration of the workflow and process that goes into Design Configurator. You start by selecting the models that you want to configure, whether that is all the parts of an assembly or if it is just the assembly file itself. There are different ways to configure it. I just used a very simple table as an example. It could be something like a semi-trailer or any other assembly that you can think of. But in this case, I just wanted to give a simple example that shows how we get to some of these more complex configurations. But we start with models, we determine our inputs, we can specify different rules such as maximums, minimums. Then we define the model actions, which are what the model wants to do, such as change variables, add models, remove models. You can add and remove features technically. And then last but certainly not least is that play or configure button where we actually run the configurator. Next, I'm going to show a bit more complex version. Still a little on the simpler side, but you can see that I have a few more parts selected here. And this one has been pre-configured, so we don't have to go through that entire process of setting up the inputs and rules and all that. So you can see the various inputs we have, the various rules that are on this one. And I wanted to point out here that it checks the inputs and some of the file names on this to show, because it's checking for the names of various parts, assemblies, and draft files. And as you can see there, we can actually do some actions with even a draft file. So first, I'm just going to show various design change a couple of the values. And then I'm going to leave it gray, but I will choose a different lock type. Some of the lock types there are only available at various sizes, so you can even have rules that determine what the choices you have in your configuration. Even those are configurable. So you'll see I've set my parameters. It added the locks that I selected, changed the size, and then added the mounting holes on the back. So you can see that those features have been added. Now I'm going to do another one, because where this really shines is when you have many orders or many configurations to do. If I have several in a row that I need to change or get orders for, I can do that at a pretty rapid pace. So I set my width, height, and depth. I'm going to change the lock type again, and this time I'll do blue. And I'll turn off the mounting holes. So this one will be closer to more like a taller cabinet, but you'll see that the features change a little bit. One thing that's also worth noticing on this example is that the color, the model itself is changing, but something else that's changing is the name of the assembly at the top. Each time in this configuration, each time we go through a configuration, it changes its own name to a different one, and that name is based on the options you select. So if it's blue, one of the letters in its assembly name changes to blue, or to B, I should say. And if I were to select red, it would be R. So that assembly name is kind of like a code. Some of the benefits of Design Configurator, kind of like we mentioned in those industry trends, is that the configurable designs are able to be completed much faster and still meet the customer's requirements. They use considerably less engineering time to configure any configured to order products or engineered to order products. And then of course, any kind of automation takes out that inherent human error, because the drawings, the bill of materials, things like that are all automated. Something else I wanted to show was some of the larger examples with Design Configurator, like what is possible with it. Because I showed something as simple as a table, with just a few variables. I showed sort of a cabinet that has, some lengths and widths. Keep in mind that this is also possible to use with much larger, more complex assemblies. It doesn't have to be even dimensions used as your parameters, as long as you can determine, the engineering requirements. The inputs could be whatever you can think of. This is, like I said earlier, kind of like programming your assembly. So if you can put it into a formula, if you can think of it logically, you can probably have Design Configurator calculate it. You can see one of the examples down there is almost like a configuration of a conveyor line. And one of these other ones shows a different configuration assembly. You can see the amount of inputs is a little higher, although the models in this case, it only has the assembly itself, but there's quite a few rules and model actions in place here. But this one works a little differently. I'm going to start with just a conveyor, and then this one will add a conveyor. In particular, this loops though. So now I'm going to select the split, and I choose the direction, and then I choose which of these I want to add to, and then I'm going to add a machine. And then that adds itself to the next. And then I'm able to add another machine. And once this one's completed, I will be able to continue on that right branch. So now I'm going to go on to the right, and I'm going to add a curve to it. And then from the curve, I can keep going. I'll add a straight. And I could change the length, but I'll just leave it standard for now. And you'll see that it adds itself. So some of the things that were added to Design Configurator are the ability to loop. And so in theory, I could just keep going as long as my computer can continue to render these conveyor belts. I would be able to just keep adding more to it. And additionally, there's also another feature that was in here that I think is very powerful, which is sub-configuration. It didn't really show it here as much, but you can actually bring in a sub-assembly that has a configuration on it, and then that sub-assembly's configuration will start. And so you can have various looping and sub-configurations, in a row to build some extremely complex and large models if necessary. So for Design Configurator, that kind of wraps it up for the the features, what's possible. Keep in mind that these were all example assemblies. It doesn't have to be a conveyor belt or a cabinet or a table. It could be just about anything, like trailer, a pneumatic cylinder, anything along those lines. All of it is possible. Something to keep an eye out for. It's not quite available yet, but there's also another addition on the way for Solid Edge Design Configurator, which is the Solid Edge Design Configurator Connect. This will be a tool that allows you to access the configurations you create through the web or through your web browser. This could allow your customers, for example, to access your configurator so that when they want to order something or something along those lines, they can just go use the configurator. And it could be a very powerful tool for both customers, yourselves, maybe a sales team, things like that. It's just another way to access it. You can access it through a web browser from anywhere. And I think it'll be a very powerful tool. So keep an eye out for that. And of course, we would love to hear your feedback. I believe we're going to have a survey link. You can scan the QR code if you'd like, or a link will be posted in the chat. So feel free to respond there. And I'm going to hand it back over to Joanna.
Thank you for that presentation, Jason. Before we get into the open Q&A, I just wanted to let everyone know, like Jason was saying, that we do have a survey about this webinar. You can get to it either through this QR code, or I just dropped a link also in the chat. We would really appreciate your participation, as it helps us grow and continually create better events and content. So if you have a couple of minutes to spare, and go ahead and get that pulled up and finished, we would really appreciate that. So now we can go ahead and get into the Q&A. If anybody has any questions, go ahead and type it in. I did not see any come through during the presentation. So do we have any questions out there? There's a... Trying to unmute you, honey. Oh, there we go.
Hi, Jeff.
There it goes.
I did see your question there. You asked if the standard height changed for conveyor. What process would that require? So that would get a little complicated, but there's various ways that you could calculate it. So if, depending on how your conveyor would be built, or whatever component you're trying to assemble, you can do a lot of the rules through the variable table. If many of the dimensions and formulas, like the variables, are driven by formulas, you can have a lot of it sort of drive itself, and then use the configurator to change some of the inputs. And then as long as the formulas are correct and those inputs are correct, then everything can kind of follow suit. Of course, that is an assembly by assembly basis. A lot of use of like patterns and things of that nature, so that the individual instances of a pattern get copied. I got a question from Omar Associates. He's asking if the models have to be synchronous, or if they can work in ordered as well. It looks like so they can be either one, because both types of models have variables involved, and both are editable. In fact, you could do this with models that are both. Of course, depending on what you're trying to build, certain things will lend themselves, certain models will lend themselves to other types of modeling, but either one or both. All right.
All right, guys, it looks like Austin's typing. Here we go. We did get another question.
Hi, Justin. So it does differentiate from family of assemblies a little bit, because family of assemblies, you kind of have to have each configuration pre-configured. This kind of allows a much wider array of configurations, and the values can't quite be, they're less variable, in the sense that, if you needed to make a new one, you'd have to go make a like a new family member, add all of the values that correspond, and then it would generate that new member. In addition, there's actually more capability in Design Configurator. The number of tools and model actions, rules, etc., is a little bit, there's just more available there. Yeah. Also, that that was a feature that I didn't mention specifically, but the you can actually use it in conjunction with family of assemblies too, which is an interesting thought, something even more to kind of experiment with.
So as you guys can see on the screen here, for a limited time, which is through January 31st, you can get 30% off licenses of Solid Edge Design Configurator. There's no maximum or minimum limit to the number of seats, and it's offered through our subscription and hybrid ZAS licenses. If there's no more questions, that's going to conclude our Design Configurator webinar. Thank you all so much for being here today. We do really appreciate it. Have a slide that should have Jason's contact information up here. Perfect, as well as a phone number for our sales team. So if you guys have any more questions or looking for some more info or one-on-one conversations on the Design Configurator or anything else for that matter, please feel free to reach out to any either one of these contacts. And thank you again, everyone. Have a very great day.